internal web inspector client. We really use this concept everywhere where we need to would use WebKit types inside web core, but then go for the client thing. No. So one of the most famous ones we're seeing inside the page and frame are the Chrome client, which is responsible to provide information to JavaScript, like what is the size of the frame, am I focused or am I not focused, or to handle the prompt that you can do in JavaScript to get model feedback of, like, you want a number, you can use prompt in JavaScript and show it. This is dispatched through the Chrome client. The frame loader client is really responsible for loading, and because it's a client, it can do policy. So every time we try to navigate to a new page, in example, a user has clicked on a link, the frame loader client is asked, do you want to open this page? And this, of course, needs to be handled in a platform-specific way and even exported to the API. So sometimes in Epiphany, if I press Control and open a new link, I want it to be opened in a new tab. So we need to be able to send this navigation into the WebKit layer. And of course, drag client for drag and drop, editor for input methods. So in one example, to understand how the client really works is to look into the frame loader client, which is called for frame loading. So the interface sits inside the webcore directory. And everything should be a pure virtual function, and this one is not. And there's a reason for it not to be. Okay. So everything else should be pure virtual. Okay. And this is called from a class called frameloader. So every time we use a client, we have a something client.h header file with the interface. We do have a something.h and CPP implementation, which is using the client to do the work. And finally, we do have an implementation for GDK inside the WebKit directory. So it's WebKit GDK webcore support and frameloader client GDK CPP. And there's a lot of things. So in example, emitting a signal when the load status finished or the load was done, or even stuff that is not implemented by us and we probably don't want to implement or should implement at some point. And we do emit a lot of signals from this class as well, like progress for page loading, or the policy check I mentioned, which is using a signal with a return value, so people can decide if they want to handle it or not. Yeah. And Chrome client is in a similar way. So the implementation sits in webcore support again, and the important things like JavaScript can ask for the window rect of the screen or of the widget, and we use the GDK widget to do it. Or JavaScript can ask to have the window resized to a specific size, and we're emitting a signal, or we're just setting it and see if it can be auto-resized, and if it can't be auto-resized, we will just stop it, and if it can be resized, we move it and resize. JavaScript can grab focus or unfocus widgets, or it can ask to open a new page in a window, and we do the same. We get a web view back from the call where it should be opened. Can run modal. Yeah, JavaScript can control if the toolbar should be visible, and we're just handling it by setting a property, which can be connected by the notify framework of GObject. Here, so Chrome client is actually the bridge from the stuff which is around the web frame to the JavaScript world. Okay, so we have seen how the GTK widget interacts with the web core to send in events. The other thing comes from the button on how is web core actually drawing, and for this we also just use a generic way. So in all cases we have abstractions. An example for painting, we do have a class called graphics context, and we have different implementations depending on the platform. So we do have this platform directory which is responsible for the platform integration, and we have subdirectories. One is for graphics, and inside graphics we do have this generic interface called graphics context, even 3D, but just this one. And we do have port specific or library specific subdirectories. So for GTK we're using Cairo to paint, which means we do have a Cairo subdirectory, and an implementation which has the graphics context base name to show where it's coming from, and the port name suffix, so you can differentiate from the file name which port it's using. So the concept is we do have a generic header file inside one of these platform directories, and we do have a specific implementation inside inside a subdirectory, which is then suffixed with Cairo or whatever the port is. And we're using the same for text and Unicode handling, for network abstraction, and sometimes when we don't implement a specific function, or if a new function is added to the platform abstraction, people will put not implemented macro inside these functions, and they get printed by when running into this function. So you get a log message, blah 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 function is not implemented, and it's a great way to get started to code. If you see it not implemented, you can figure out if you want to implement it, and if you decide that this port wants to implement a function, you can just try to implement it and send a patch, which really is a very nice way to get started, because it's just one function, and there's a test case that is testing this function, and you can easily get started doing this. And for networking we have two more classes. So one is the resource request, which holds the URL you want to open, HTTP headers, or if you want to make a post with like a form attached, you have also the form data into the request. And then we do have this platform specific class called resource handle, and the resource handle gets a resource request, and it can also get a resource handle client assigned, which is again the same client model. So whenever we have some information to dispatch, like we have started to load or we have received data, the resource handle client is called with the specific functions. For GTK we're using libsoup, so we do have the directory called web core platforms network soup, and there should be a resource handle class inside there. And again, it's called resource handle and then the suffix for the library used. And the start implementation figures out if it's worth loading something into a page, is then getting the URL from the request, the protocol, and soup is actually only handling HTTP, so for local files we have to fall back to GIO, which is done over here. So for HTTP we start the job as a soup request. So we get the default session and convert a request into a soup message and then connect to signals. Then handle uploads of files. An example, if you want to upload a picture to Flickr or somewhere else. More handling of this. Then we take a reference count on it. And finally, we're sending off the information. And to provide callbacks and to provide information when something was downloaded, we're getting, so this function is called when this resource was closed from GIO in this case. We get the resource handle client and we call did finish loading on the client. So whoever is making a request provides a resource handle client, and whenever the request is handled, the client is getting called with the data or with the information it asked for. Good. It's almost 6 minutes before time, so I can either continue with fonts, or are there any questions regarding WebKitGTK or to what I said? I know it was pretty technical, and just with one guy ever having used WebKitGTK for an application, it's a bit too much, but do you have questions regarding the port integration or state of WebKit in general? Or a short mentioning, there's going to be a more high-level talk by San Lopez in about 30 minutes, or so if you want to see more what you can do with WebKitGTK, this talk is more interesting. Anything? Otherwise, I'm going to ask random questions to you, or you have to take a test, or.
Oh no, I will wait. I have a question about the GIO API. Does GIO depending on genome volume management? I mean, if you want to use the GIO to write the local files, do you need genome supporting, GNOME, genome supporting? Or
I think some can correct me if I'm wrong, but for GIO you can have different modules to provide access, and I think the file module is inside glib.
So it's just inside glib?
It's glib.
Okay, thank you.
One issue most people have with trying to compile glib themselves and then trying to get WebKit run on a device is GIO tries to determine the MIME type based on the extension, and you need to have XDG desktop files on a